So we know that fights are costly. Have you incorporated this parameter in your simulation?
The question is, are fights cost? We know that fights are costly. Have I incorporated that into the simulation? The answer is I haven't yet. There's another set of models that have been done by a colleague of mine, and they were asking a slightly different question. They were asking the question, when do we expect winner effects to evolve, and when do we expect loser effects to evolve? And they specifically had lots on the cost of fighting. I assumed that these things were already in play or not, but I did not manipulate the cost of fighting at all in these models. So in essence, there was no cost. There was no differences between individuals in the cost of fighting, so that if you fought, it didn't have any. It didn't deplete your resources. It simply changed your probability of winning again. And I'm assuming that where you end up in the hierarchy determines how much you get in the way of resources.
Because in a sort of experiment, the numbers suggest that there is some cost, because the winners tend to be at the bottom of the hierarchy more often than the neutral fish.
The winners were at the top of the hierarchy.
Yeah, but four of them ended at the bottom compared to the neutral ones, just one of them.
Right, so that's right.
And I think it's related to the energies.
No, I agree, and you know, you certainly would expect that the kind of, you know, what we saw in that video, that's gonna cost some real energy. So it needs to be done. We haven't done it yet.
Yes. Wouldn't there be some effect in testing this hypothesis on humans? I mean, species is well known. Its hierarchy is also well established. Wouldn't it be more effective than in chicken?
Right. So the question is, why haven't we looked at this in humans? And the answer is that there is some, but a very little experimental work that's been done on humans. But there's a lot more correlational work where basically you can go into these large databases that exist, for example, in sports, and you can look and see whether or not the probability of prior wins affects the probability of future wins and the probability of, and so you can look at streaks that teams get on, where you have to assume that before the streak there was nothing magical, nothing major changed except that they happened to win a game, and then all of a sudden they started winning games. It's not like their star came back or something. You'd have to make sure that wasn't the case, but you could do that, and there do seem to be these winner and loser effects, especially loser effects. In general, loser effects are stronger in non-humans as well, and in humans. We tried a long time ago we put together a proposal where we would look at experimental work on humans, where we would let people play computer games, and we could manipulate the size and strength of the avatars that individuals might have, and we would look at the kind of rules that they use to play and whether or not winner and loser effects popped out of that. But again, no money, so happy to do it.
I just didn't understand how the simulation starts, because you said that at the beginning all chickens have the same ability score.
Right.
And if I understood, if they fight, if they assess that they are better than the other.
Right.
So how did they start?
Right, so what happens is they all begin with some same value. Let's say they assess themselves as 10. So when you pull two individuals out of there, the first two are going to have exactly the same score. Then the probability that individual 1 beats up individual 2 is just 1/2. And so the computer randomly picks a number between 0 and 1/2, and if it's...
But they will engage in fight. They will not,
It depends on what rule they'll only you set up. So if you say, I will fight somebody who's my size or bigger, then they will fight. And so that's the general kind of rule you use. Otherwise you wouldn't get anybody doing anything. Yeah.